Hello, welcome to our look at electrons and how we use electrons to form bonds. First off, we're going to review the Bohr model, which is B-O-R-H. The Bohr model, and that's the model where you show each of the electron shells. So if we have something like hydrogen, hydrogen only has the single electron shell. It only has the single electron. Helium would have 2 electrons in that first shell. Since it fills up, lithium would have that first shell filled up. And then you'd have to move it to the next shell with beryllium, then doing the same, 2 and 2. Boron would have 2 and 3 on the outside, and so on. Carbon would have 4, nitrogen would have 5 on the outside, oxygen would have 6, fluorine would have 7, and we'd end with neon at 8. That shell would fill up, so then we would go back down here to sodium, which would have 2, 8, and then a third circle where we would have 1 single dot. And we go onward and onward till we filled up all the different elemental rings for the elements. But you probably already know that, as that is several weeks old at this point. So we're going to move on to something that is also a review, and that is valence electrons. And that is the electrons that are available for the chemical reaction. So for hydrogen, you would have the 1. Helium, you would have the 2. But then when we get to lithium again, lithium only has 1 because that inner green one that we were looking at in the previous one, that inner shell, where we have the 2, those are not available for chemical reaction. So we can ignore that inner shell of electrons and only focus on the outside. So then we'd move to beryllium. And once again, we would only have the 2. Boron would only have the 3 because valence electrons are only that outermost shell, only the electrons on the outside shell. So even if you got to something like potassium, which would normally look something like this, if you did that Lewis dot, or you did the Bohr diagram, you'd have 4 different circles. But in the valence electrons, we only focus on the outside. Potassium would have 1 single valence electron because we'd ignore everything that's not on the outside. All right, let's move on to something else. Let's look at Lewis dot structure. This is building directly off those valence electrons. But this removes the circle. So for this, hydrogen has one valence electron, but you remove those shells on the outside. and only put the dots. So then helium would have 2. Lithium, 1. Beryllium, 2. Boron, 3. Carbon, 4. Then we get to nitrogen, and we get 5. If we are above 5, we start doubling up the electrons. Nitrogen would have 5, so it has 1 doubled pair of electrons. Oxygen has 6, 2 doubled up pairs of electrons. And finally, fluorine, 3 doubled up pairs of electrons, 1 unpaired, which would lead us to then neon. That outer shell can only hold 8 doubled up pairs of electrons. So then we go to sodium. Since we're only focused on that outside shell with the Lewis dot, we're back to 1. And so on as we go through. So that should be something that you have already pretty much learned. But when we want to start combining them, we have to look at all these different electron configurations. How are all the electrons put together? So let's start with, salt. Salt is a pretty easy one. You have sodium and you have chlorine. Now, since we have one metal and one non-metal, this is a thing called an ionic bond. I-O-N-I-C. That means we make ions. Ions are anything that has more protons than electrons or fewer protons than electrons. So for an example, if you have, we will say if you have hydrogen. Hydrogen wants to get to either 0 or 2. It wants to either have a full electron or no electrons. So since it starts with 1, this would be just neutral hydrogen. 1 electron and 1 proton in the hydrogen. If it gains another electron, then you have 2 electrons and 1 proton. Each electron is a negative, each proton is a positive. Protons minus electrons gives you your charge, which would be a -1 charge. So this hydrogen with 2 electrons would have a -1 charge. If we did it the opposite, where hydrogen got rid of its electron, then you have 1 proton minus 0 electrons gives you a charge of +1. So with no electrons, this hydrogen is a +1 ion. And you can do that for any of these. Say that you have like calcium, has 2. Well, it's much closer to getting rid of them, so it will much more likely get rid of its electrons. Well, calcium has 20 protons. It has 18 electrons now that it got rid of its 2 on the outside. 2 on the first shell, 8 on the second shell, 8 on the third shell. So 20 protons minus 18 electrons gives you 2. So calcium will often form a double positive ion, a +2 ion. So let's move this back to sodium and chlorine. Sodium starts with 1. Chlorine starts with 7. Both sodium and chlorine want to get to 0 or 8. Chlorine needs 1 to get to 8, and sodium needs to get rid of 1 to get to 0 to make them both happy. So what will happen is the sodium will go to the chlorine, donate that electron to the chlorine, and that will lead to sodium having no electrons. Sodium has 11 protons, and now it only has 10 electrons left after getting rid of that. That would give you a +1 charge. Chlorine has 17 protons and 17 electrons, but it just gained another one. So chlorine being happy with all the electrons outside is 17 protons minus 18 electrons. That gives you a -1 charge. Now you'll also notice +1, -1, they offset each other. That tells us that then sodium will bond with chlorine at a rate of 1 to 1, which you would see here. Salt is single Na, single Cl. Kind of like we did when balancing the chemical formulas. Sometimes, however, this doesn't happen where it's a 1-to-1 ratio. Sometimes you need multiples, such as with hydrogen and oxygen. Hydrogen has a single electron. Oxygen has 6 electrons. Oxygen wants to get to 8. Hydrogen wants to get to 0 or 2. So the easiest way to do that would be to donate an electron, which would give you hydrogen with no electron and oxygen with 7 electrons. The problem is oxygen is not happy yet, but hydrogen can't do anything. So the way that we make it happy is bring in another hydrogen with another electron. That can then donate here to make it happy. Now you'll notice there are 2 H's and a single O. So this leads to H's, 1 proton, 0 electrons. That would be positive. And oxygen. Wanting to be happy, it has 8 electrons now. It has 8 protons, but including the 2 electrons in the first shell, this now has 10 electrons. So it is a -2. Obviously, a +1 and a -2 does not balance, which is why we needed the second hydrogen. And this is how H2O sometimes forms. There is a second way that it can also form, which we will talk about in about 5 seconds. Because this is not the only type of bond that exists. This is an ionic bond. We also have a thing called a covalent bond. Those tend to form with things that are not metals, such as hydrogen, oxygen, carbon, nitrogen, fluorine, chlorine, bromine, pretty much everything on the far right side of the periodic table. The upper right corner of the periodic table do not form these ionic bonds because they are not metals. They form covalent bonds, where instead of one side taking the electron for themselves, they share the electrons. So let's look at water in a covalent bond. You would have hydrogen, hydrogen, and oxygen. Hydrogen wants to get to 0 or 2. Hydrogen wants to get to 0 or 2. Oxygen wants to get to 0 or 8, much closer to 8. So hydrogen is going to donate its electron over here, but not completely. It is actually going to bring itself over as well and share the electrons. Kind of like holding hands with someone. No one person really owns the holding of the hands. You both share that. Same thing here. Neither one of the oxygen or the hydrogen owns each of these electrons. They share them. They both have them. So looking at the hydrogen, we circle all the electrons that are touching it. It has made it to 2, so hydrogen is happy. This hydrogen also has made it to 2, so it is also happy. And we look at the oxygen. The oxygen circle has made it to 8 electrons. So it is also happy. Anywhere that you see the two circles interacting and overlapping, that is a covalent bond. So anywhere that you see the overlapping of the circles is a covalent bond. And you can form it with as many as you'd like. Sometimes, like if we did chlorine and carbon, if we do like carbon and a bunch of chlorines, sometimes you'll have a bunch of electrons sticking out. Carbon has 4, chlorine has 7. Well, carbon has 4 single electrons that it can bond with. Chlorine has 1, so you need 4. And then you have all the bonded electrons that chlorine already has. Draw a circle around chlorine, it's got 8. Circle around chlorine, has 8. Circle around chlorine, has 8. Circle around chlorine, has 8. Circle around the carbon, has 8. But it also shows you where those 4 bonds, those 4 covalent bonds are, where the circle intersects 4 times. Now, with covalent bonds, you also get, sometimes, everything we've talked about are single bonds. But sometimes, you get double or triple bonds, such as if we do like the molecule H, not C, HNO. You have nitrogen. Well, Well, hydrogen can come over with its 1 and donate 1 electron. But nitrogen still has 2 different places, and we only have to fill that with the oxygen. So if we do that, we bring the oxygen over here, and oxygen donates 1, but nitrogen's at 7, oxygen's at 7. Neither of them is happy, but they each have another free electron. So they form a secondary, a double bond. And if you circle everything shared by everything, hydrogen made it to 2. It's happy. Nitrogen made it to 8. Also happy. Oxygen made it to 8. Also happy. In the off chance that this is cut off of the camera, I will draw it down here as well. Hydrogen, nitrogen, oxygen. Hydrogen, happy. Nitrogen, happy. Oxygen, happy. Single pair, single bond. Double pair, double bond. But you also sometimes get triple bonds. Such as one big example would be nitrogen. Nitrogen has 5, and nitrogen also has 5. The nitrogen that exists in the air is nitrogen bonded to nitrogen. But since they only have each other, they have to make every single bond with each other. So the 3 electrons that they share must be used in that bond. Three pairs of electrons, triple covalent bond. Sometimes that will happen. So I believe that is everything that we have covered on electrons and bonds. Both ionic bonds and covalent bonds. And within covalent bonds, single bonds, using a single pair of electrons, as all these are. Double bonds, using 2 pairs of electrons. And triple bonds, using 3 pairs of electrons. So that will be it for our video today.